Hello my students, wherever you are. Today we are learning pack titration. We have finished simple titration. In this pack titration that we are learning today, we have these questions. You are provided with the following. In pack titration, it's different from simple titration. Simple titration, it was dealing only reaction between acid base or reaction between acid and carbonate. But this one deals between three solutions. Acid is first reacted with a carbonate, then now the product formed is further reacted with this product is further reacted with the base. So we have three solutions: a base, an acid, and a carbonate. So first we react the acid and the carbonate, then the product formed further will react the base. The excess acid that remains from the carbonate will further react the base to form a new product. So that's what we call it pack titration. So that's what we are dealing today. So in here we have this example. The example is saying that you are provided with the following: 25 gram of the acid, 25 gram of the carbonate, which is calcium carbonate, contains 250 centimeter cube of solution. 4 molar of hydrochloric acid containing 50 centimeter cube of water, and also 1 molar of sodium hydroxide. So we have the procedure here. First you place the acid in 100 ml beaker, then you top up with the distilled water and you label as solution A. Then after that you add the solid sodium carbonate, which is the 25 gram. You add it, then you stir it until effervescence is established. There are two options here. You can add the carbonate, the solid, with the acid, original acid 50, or you can add after diluting. There is no problem. So whatsoever you do it, you put the acid in a beaker, then you add the solid, you dilute it up to 100. Then after that you form a new solution, then you label it solution A. So then this is what you do. You fill the burette with sodium hydroxide solution. Then you pipette 25 centimeter cube of solution A, which you have prepared, which is the mixture of the acid and the carbonate, and you dilute it. Then you place in a clean conical flask. Then you add indicators, either phenolphthalein indicators or methyl orange. Mostly they use methyl orange. You can also add phenolphthalein indicators. There is no problem. So we have this table. The table is filled 25, 25, 25, 0, 0, 0 in the initial, and the final 25, 25, 25. So the first question is asking average volume. To calculate now the average volume, this is what you do. Average volume therefore is equal to 25 plus 25 plus 25 divided by 3. When you add all the 325, you will get 75. Then you divide 3, you will get it 25 centimeter cubic of the base. Which base? Sodium hydroxide solution. This is the number of moles of sodium hydroxide solution used. Out of 250, we used 25. Part B. Part B is asking the number of moles of the acid. The number of moles of the acid, the number of moles of the hydrochloric acid used. To get the number of moles of the number of moles of the base, which is sodium hydroxide, used. To get the number of moles of sodium hydroxide, we have the volume used, which is 25, and we have also the molarity of the base, which is 1 molar. Then therefore we will say 1 molar is equal to 1000 centimeter cubic. What about this 25? 25 centimeter cubic. We don't know. Then cross multiplication. We do cross multiplication. 1 molar times 25 centimeter cubic divided by 1000. Therefore we get it 0.025 moles of sodium why my pen is not operational, of sodium hydroxide. So this is the number of moles of sodium hydroxide. Good. That's what you do. Let us go other questions. We have other questions in another page. next page. We have these questions. Questions are a lot. The number of moles of the hydrochloric acid. To get the number of moles of the hydrochloric acid, which is C, you add the two. You react the two solutions: sodium hydroxide, aqueous, plus hydrochloric acid, aqueous. Then an arrow. Then you'll get it: sodium chloride, aqueous, plus water. As a reacting base, the product is salt plus water. This is a neutralization reaction. So balance the equation: sodium 1 here, sodium 1 here, hydrogen 1 plus 1, 2 hydrogen here, 2 hydrogen, oxygen 1, oxygen 1, chlorine 1, chlorine 1. So that means the mole ratio is 1 to 1. So to get the number of moles of the base, to get the number of moles of the acid, the number of moles of the hydrochloric acid, to get that, which is C, asking you have the number of moles of the base. Since the mole ratio is 1 1, the number of moles of the base and the number of moles of the acid remains the same, which is 0.025 moles that we have seen in part B. So this is the number of moles of the HCl used. Good. We have D, question D. Question D is asking the number of moles of hydrochloric acid in 100 cm cubic of solution A. So do we have the number of moles of solution A used? Yes, we have 0.025. Do we have the volume of solution A used? Yes. The volume of solution A used is this one, 25 cm cubic of solution A in a clean conical flask. That's what we used. So this is therefore what you do. The 25 is the volume used. 25 cm cubic is equal to that number of moles, which is 0.025 moles, which is the volume, which is the moles used. What about 100 cm cubic of the acid? How many moles does it contain? So we don't know X. So cross multiplication, 100 centimeter, sorry, I said 1000 here. I mean 100, not 1000. 100 centimeter cubic multiplied by 0.025 divided by 25. So here, therefore, you will get it 0.1 mole. 0.1 moles. So this is the number of moles in 100 cm cubic of a HCl. E. Question E. Question E, what do we have? Question E. Question E, what do we have? In question E, what do we have? Question E is asking the original number of moles of the hydrochloric acid. The original number of moles of the hydrochloric acid. So the original number of moles of the hydrochloric acid, how do you get it? In the acid, originally we have 4 molar of the acid and total volume 50. So we can easily get it. Therefore, this is what we do. We will say 4 molar of the acid is equal to 1000 centimeter cube. What about 50 centimeter cube of the original acid? How many moles will it be equal to? We cross multiply. Then this is what we do. 4 molar the acid times 50 centimeter cubic divided by 1000. So 50 times 4 molar divided by 1000. What do we get? Let us see it using a calculator. 4 times 50 divided by 1000. 0.2. We will get 0.2 moles. So this is the number of moles of the original acid before it reacts with the base and the carbonate. Before it reacts with the base and the carbonate. We have taken the original molarity, which is 4 molar, is equal to 1000. What about 50? What about 50? What about 50? That's what we have. We have done it. Here I mean 4. Here is 4. This is 4 molar. Okay. Now our next is we have F. We have a lot of question. The number of moles of the hydrochloric acid that reacted the carbonate. To get the number of moles of the hydrochloric acid that reacted the carbonate, which is but F, let us get into a new page. F. The total number of moles was 0.2 mole of the acid before it reacts anything minus 0.1. Then we get 0.1 more moles. So this is the number of moles of HCl reacted the carbonate. This is the number of moles of HCl reacted with the carbonate. F, after F we have Fg. So original moles you have 0.2, then you subtract the number of moles of the excess. Then you subtract from the excess. Then from the excess, what remains is the number of moles reacted with the carbonate of HCl. So we have F. F is asking the number of moles of hydrochloric acid that reacted the carbonate. Yes, we have gotten it. G is asking the number of moles of the carbonate used. To get the number of moles of the carbonate used, you react calcium carbonate, calcium carbonate solid plus hydrochloric acid aqueous. What do we get? We'll get calcium chloride aqueous plus carbon dioxide gas plus water So here we have oxygen 3. This is 3. My pen is not operational. This is carbon dioxide, not 3. Carbon dioxide, that's how it's written. So let us balance the equation before we jump into anything. Let us balance the equation. So calcium 1 here, calcium 1 balance, carbon 1 balance, chlorine here 1, chlorine here 2. Then we put 2 here. Then chlorine balance, hydrogen 2 balance, oxygen 1 plus 1 3 2 plus 1 oxygen 3, oxygen here 3. So the equation for the reaction is 1 to 2. Then in this case we have the number of moles of the acid reacted the carbonate. We have 0.1. Then therefore we will say 2 molar is equal to 0.1. So let me use the other pen. So 2 molar is equal to, from the acid, is equal to 0.1 moles. What about 1 mole ratio here? We don't know. Then you cross multiply. 1 times 0.1 divided by 2. What do you get? 0.1 divided by 2. You get 0.05 moles. That's how you get it. But G. Then H, we have H. H is asking the mass of the sample of the carbonate. If calcium is 40, oxygen 16, carbon is 12. So therefore, to get the mass is equal to number of moles times RFM. And we have number of moles of the carbonate 0.05. RFM of calcium carbonate is equal to calcium 40 plus carbon 12 plus 3 times 16 oxygen. Total you'll get 100 when you add all of them. Therefore, number of moles is equal to mass is equal to the number of moles, which is 0.05 times 100. Then you get it 5 gram. That is the number, the mass of the carbonate. The mass of the carbonate used. Out of 25 we used 5. So the next question is asking which is I, the percentage purity of the compound. To get now the percentage purity, the original mass was 25. the new mass is 5. Then